Network routing. Ethernet requires that all nodes to be directly connected to the same local network. This requirement is a major limitation for a truly global network because it's not practical to physically connect every node to every other node, rather than require that all nodes to be directly connected. The source and destination addresses allow the data to be routed over different networks until the data reaches to the desired destination node, as shown here. In this diagram, we are seeing two Ethernet networks, each with separate IP address ranges. Here, in this lecture, I will explain how the IP uses this model to send the data from the node at one network number 1 to network number 2. The operating system network stack node here encapsulates the application and transport layer data, and it builds an IP packet with a source address of 192.168.0.101 and the destination address of 20.0.1.45. Then, as a step 2, the network stack needs to send an Ethernet frame. But because the destination IP address does not exist on any Ethernet network that the node is connected to, the network stack consults an operating system routing table. In this example, the routing table contains an entry for the IP address 20.0.1.50 or 45. The entry indicates that the router on the IP address 192.168.0.101 knows how to get that destination address. And then the operating system uses ARP, address resolution protocol, to look up the router's MAC address at this 192.168.0.101. And the original IP packet is encapsulated within the Ethernet frame with the MAC address. The router receives the Ethernet frame and unpacks the IP packet. When the router checks the destination IP address, it determines that the IP packet is not designed for the router or destined for the router, but for a different node on another connected network. The router looks up the MAC address of this IP address 20.0.1.45, encapsulates the original IP packet into new Ethernet frame and sends it onto network number 2. The destination node receives the Ethernet frame, unpacks the IP packet, and processes its contents. And this routing process might be repeated multiple times. For example, if the router was not directly connected to the network containing the node of 20.0.1.45, it will consult its own routing table and determine the next router it could send the IP packet to. Clearly, it would be impractical for every node on the network to know how to get to every other node on the internet. If there is no explicit routing entry for a destination, the operating system provides a default routing table entry, and this is called the default gateway, which contains the IP address of a router that can forward IP packets to their destinations.